All right, guys, so we're going to wait till next class for problem number 1 because I kind of enjoy this historical anecdote about the math that we've been learning. So we'll come back to that. When factored completely, which of the following is equivalent to the expression x squared minus 12x plus 36? So because this is a trinomial with x squared alone, we're going to use sum and product. So we're looking for two numbers that sum to negative 12 and have a product of 36. Those numbers will be negative 6 and negative 6, which can be written as x minus 6 squared. Because this is a square, this is called perfect square factorable. And what we saw today in class is that sometimes this can be a really helpful way to solve problems like number 3. So let's take a look at problem number 3. So we've got x squared plus 8x minus 2 equals 0. And I might try this with sum and product to start. But then you notice that there are no numbers that multiply to negative 2 and add to 8. So sum and product is out. So instead what we need to do is we need to have a better number here than the negative 2. So how can we get rid of the negative 2? Well, we add 2 on both sides. That gives us x squared plus 8x equals 2. And now we're thinking, what number would we rather have had there? Well, we would have rather had some number that makes it perfect square factorable. And so sometimes this number can be a little tricky to figure out. So the way I like to do it is I like to imagine what would the factors have to be in order for things to work out the way they should. So x times x is x squared. And then we're looking to make it perfect square factorable. So we need the same numbers here and here. And those numbers have to sum to 8. Oh man, I need water. But we're going to keep going through it because this is a video. So two numbers that, same number, sums to 8. So it has to be 4 and 4. Which means that we really needed to have a plus 16 on this side. But if we add 16 on this side, we have to add 16 on this side as well. Now that gives us equals to 18. And the same way that we rewrote this one as something squared, it's very helpful to rewrite this one as something squared equals 18. Now, this start equation is better than any equation we've seen before because you only have one x, so you're going to be able to isolate it. So let's take the square root on both sides to cancel out the square. That gives us x plus 4 equals positive root 18, or x plus 4 equals negative root 18. And then the final steps are to subtract 4 on each side, and we get x is equal to negative 4 plus root 18, and x is equal to negative 4 minus root 18, and we're done. This equation is going to be solved in a really similar way, so you figure it out. For number 5, solve the following equation. Okay, this one's a little crazy looking because we've got everything on this side equal to a bunch of stuff on that side. Now, my instinct is to make this equal to 0 to try to factor it. That gives us x squared plus 16x minus 9 equals 0. So we're looking for two numbers that sum to 16 and have a product of negative 9. And that's negative 3 and 3. That's not going to work. Negative 9 and 1. That's not going to work. Nothing works. So sum and product is out. So instead, we need our new technique that you guys figured out where we replace this number with a better number. So we get rid of that number on both sides. We add 9. That gives us x squared plus 16x plus some missing number equals 9. And now we think ahead. Okay, we want to factor this, but we want it to be the same factor. The same factor here and here. So we have x plus, okay, that number needs to add to 16 with itself, so 8 and 8. But if we have 8 and 8 there, it must have been plus 64 here, so we have to add 64 on both sides. And that gives us 73 over here. Then we get x plus 8 squared equals 73. And perhaps at this point, you can jump straight to the answer where you see the answer right away is x equals negative 8 plus root 73, and x equals negative 8 minus root 73. Now, for the next one, we're going to do the first step together, and then I think you can figure it out. So the first step here is, what's different about this one? Now, hopefully you see the 2 there is actually pretty different. And that's going to really mess us up when we try to do our sum and product factoring to get the same factor, perfect square factorable. So my first step here is actually, how do I get rid of that 2? And the whole thing can be divided by 2 on both sides. And it actually works out really nice in this case. Oops. Now, once you do that, it becomes a problem very similar to all the ones we've been doing before. So I'm going to actually let you solve the rest of it. Now, completing the square is actually the name of this method. And we're going to talk more about problem 7 next class. So you don't have to do this one. See you guys next class. Enjoy your day off. Bye.